All right, so we're going to take a look at 17, which is regarding constructing a stadium. So you have a track and field playing area that is in the shape of a rectangle with semicircles at each end. This is your typical track. It is not something weird. It's just like what you go around when you're doing the mile or if you're track. So you have a rectangle, and then you have a semicircle on each end, and those are true half circles. I think I drew them a little skinny, but they're supposed to be true half circles. You know the distance around the track is 1,500 meters. So that is all of this going around is going to add up to 1,500. The challenge in this problem is the fact that you're dealing with a circular shape and a rectangular shape, and those area and perimeter equations are very different. So the question is, for those of you that have done this problem, what did you assign to be your variable? Rhea?
So mine's kind of weird, but I did half, like, I did the radius as a y, just because it's easier for me. And then I did the length of the rectangle as x.
Okay, so you did a two variable system.
Yeah.
Did anyone do a one variable system? Tyler?
I'm getting second thoughts on whether this is right or not, but I just used the radius in mine.
Okay, so if you call the radius r, you could call it x as well. I'm just going to label that r. Then you know the entire width of that rectangle is 2r. Okay, so we know the width of the rectangle is 2r. What would the two curvy sides be in their length then, if that's 2r? Tyler?
2 pi r, because they make a full circle together, and that's circumference of a circle.
Okay, so each of those is 2 pi r, which would make up the whole circle is 2 pi r. So this is pi r and pi r. Think of it this way. Pi r plus pi r is 2 pi r. 2 pi r is the circumference of a circle. Okay, so questions on that so far? Now, to find the remaining length, the length across the top and the length across the bottom, consider we have 1,500 meters starting off, and we have already used up 2 pi r meters, because we have used pi on one side, pi on the other side. So we've used up 2 pi r meters. So I'm going to subtract what I have used up there, but then we have to spread that length amongst the two sides. So that is 15 minus 2 pi r divided by 2. Right? So the total we had to stretch around the track minus what we've used already, the 2 pi r all over 2, because you spread it across two sides. So in other words, it's going to be 750 minus pi r. Just dividing both of those terms by 2. Questions on that? Now, it said, what should the dimensions of the rectangle be so that the area of the rectangle is a maximum? The of the rectangle is a huge deal here, because you're maximizing not the total area on the inside of the track, just the area of the rectangle. So since I'm maximizing this, I'm going to make an equation for area of that rectangle. We know the area of a rectangle is length times width, so it is 2r times 750 minus pi r. In other words, if I multiply this out and switch the order of the terms, it's negative 2 pi r squared plus 1,500 r. Questions on that? Now this is going to be an upside down parabola because the lead term coefficient, the a, is negative. We know the area will be maximized at the vertex. So let's calculate the vertex. So the vertex normally is an x equals negative b over 2a, where we're dealing with r. So r equals negative b, so negative 1,500 over 2a, which is negative 4 pi. So that is R. So that's gonna be 375 over pi. Because 1500 divided by 4 is 375. Negative divided by negative over positive. So that is the radius here that will maximize the area of the rectangle on the inside. They don't even ask me the area, so all I need is R. But in order to answer the question, what are the dimensions? I'm going to use yet a third highlighter color. Dimensions of the rectangle are 2R by 50 minus pi r. So 2R is going to be doubling that R value. So it's 750 over pi, that is my 2R, by, and then I'm going to calculate 750 minus pi times R. So I found,
Where did you get the 750 over pi?
2R. Here, let me use a
Five.
highlighter.
Divided 1500 by 2 pi r, you got 750 minus pi r.
That's like the dimensions, and then 2000 R is.
So the length is 750
Yeah.
minus pi r.
And what equation are you putting back?
Okay, hang on, let's do some highlighting. The highlighting will bring it, here's 2R. And so I'm saying 2R is 750 over pi. And that is true because R is 375 over pi.
Oh. So putting it into that.
Well, I need to know the dimensions of the rectangle. The dimensions of the rectangle are 2R by 750 minus pi.
Okay.
Those are the dimensions. So this is 2R by, and then I have to calculate what is 750 minus pi r. So 750 minus pi r is going to be all of this business, which is going to be 375. So that is 2R, 750 over pi is 2R. 750 minus pi r is 375. Because in this expression, the pi's cancel. So I think what makes this thing hard is there's many things to select as your x, okay? I have done the problem twice today. Some people selected the curve of the circle as their x. Tyler selected the R as their x. Some ways are slightly better, but you just have to pick one and then deal with the consequences. They all are going to have really weird expressions because, again, we're combining circular things with rectangular things. So we have pi show up. We just have to not be stressed out by that. Questions? Tyler?
So I think I understand what you did. I got it wrong. I assumed because of our entry problem yesterday that the maximum area of the rectangle we needed has to be a square.
So that is wrong because you have these circular caps on the sides. So it changes the amount of area. It's not a rectangle. It is two straights with curvies. So the same rules will not apply because you need to have straight parts and you need to have curvy parts. So there's no way to get a square out of this.
Isn't the question just asking for the area of the rectangle?
Yes, but these sides have to be circular and double the radius has to equal the side length of the rectangle. So that is precisely why I took you through that whole process of solving it yesterday, because it's not always just going to be a square when you have other constraints.